Dark matter. In the silent sea of night, when all we can see are pinpricks of light scattered across an endless void, our minds are drawn to what lies in the darkness between the stars. We gaze into the cosmos and glimpse a troubling truth. Most of what exists is not what we can see. Not stars, nor planets, nor glowing gas. Not us. An invisible thread weaves itself through the fabric of the universe, holding everything together. We call it dark matter. It is a name born from absence, not because it is made of shadows, but because it does not shine, reflect, or absorb light. It does not shimmer in the X-ray, hide behind a spectrum, or even flicker faintly in the radio waves. By all measures of human observation, it is not there. Yet, it must be. Without dark matter, galaxies would unravel, stars would drift apart like mist on the wind, and the grand cosmic web that binds clusters of galaxies together would never have formed. Its gravity acts like a hidden hand, sculpting the cosmos in secret. The story begins not in the far future of science, but in the dusty archives of the early 20th century. In the 1930s, astronomer Fritz Zwicky studied the Coma cluster of galaxies, a sprawling hive of starlight drifting far beyond the Milky Way. He noticed something strange. These galaxies were moving much too fast. According to the mass we could observe, stars, dust, gas, they should have flown apart long ago, but they remained bound. Zwicky coined the term Dunkle Materie in German, dark matter, to explain this missing mass that seemed to hold the cluster together. At the time, few took his claim seriously. But decades later, something remarkable happened. In the 1970s, Vera Rubin, gazing into spiral galaxies with keen instruments and patient eyes, saw galaxies swirling in a way that defied expectations. The stars at the edges were moving just as fast as those near the center, an impossible balance unless some unseen force, some cloaked mass, was lending its gravity throughout. Since then, the evidence has mounted like a growing tide. We see it not only in the motion of galaxies, but in the subtle bending of light from distant quasars, an effect called gravitational lensing. Light curves around invisible shapes that bear no correspondence to the matter we can observe. We see it in the way galaxies cluster, in the ripples of the cosmic microwave background, in the eerie echoes of the Big Bang itself. A silent majority, perhaps 5 times more plentiful than ordinary matter, is silently keeping the universe stitched together. And yet, we have never seen a single particle of it. Physicists have spent decades searching for dark matter with exquisite instruments, some buried deep beneath the earth, shielded from cosmic rays, waiting for a whisper, a nudge, a signal from these elusive particles. Detectors filled with noble gases or supercooled crystals wait in the stillness, listening for a collision that has, so far, never come. Satellites scan the skies for high-energy clues, searching for the decay of particles that may not exist, seeking annihilations that might never occur. The search is scientific and meticulous, but it is also philosophical, bordering on mythological, as if we are chasing phantoms across the void. There are theories, of course. Dark matter might be made of WIMPs, weakly interacting massive particles, which are heavy, stable, and interact so subtly with normal matter that they slip through it like mist through a net. Others suggest axions, strange, almost ghostly particles with properties that might help explain not just cosmic structure, but symmetry in the laws of physics. There are even more exotic proposals: sterile neutrinos, hidden dimensions, modifications of gravity itself. It is a mystery with no confirmed answer, an open wound in the heart of modern astrophysics. In this ocean of uncertainty, there are lesser-known clues that whisper from strange corners. One such whisper is the Bullet Cluster, a cosmic collision between 2 galaxy clusters that pass through each other like ghosts in the dark. As their luminous gases collided and slowed, dark matter, invisible and unaffected, continued its smooth course. We know this not because we can see the dark matter, but because of how it shapes the light behind it. It is one of the strongest visual proofs of dark matter's separate identity from ordinary matter, like footprints of an invisible wanderer across the sands of space. And then, There are even more mysterious signals. The 3.5 kV line, a weak X-ray emission spotted from distant galaxy clusters, has teased researchers for years. Some think it is a signature of decaying dark matter. Others believe it's a statistical fluke. It flickers at the fringe of detection, existing in that liminal space between discovery and speculation. What makes dark matter so deeply compelling is not just that it is unknown, but that it is everywhere. It surrounds our galaxy, forming an immense halo that stretches far beyond the furthest stars. It cradles us, permeates us, and flows through the Earth as if we weren't here at all. Every second, trillions of dark matter particles may be passing through our bodies without leaving a trace. In this sense, we are not so much observing the universe as we are drifting quietly within its invisible bones. And in its presence, we are reminded of our own limitations, that the universe, vast and ancient, holds structures and truths that may remain hidden for centuries, even as our tools grow sharper and our minds more imaginative. Dark matter is not simply a scientific problem to be solved. It is a mirror, showing us the gaps in what we know, and a compass guiding us toward what we have yet to understand. It shares something with ancient mystery, like the symbols carved into stone long before language, or the haunting notes of an untranslatable song. Perhaps one day we'll understand it, perhaps not. The scientific journey to uncover dark matter is ongoing. It is meticulous and relentless, but without guarantees. Its answer may lie in tomorrow's equations, or it may remain just out of reach, a cosmic riddle scribbled in ink we have not yet learned to see. In the grand theater of the cosmos, dark matter plays a silent role, never delivering a monologue, never standing in the spotlight, but always shaping the stage. We live in a gravitational web formed by its presence. Without it, the stars would not cluster, the galaxies would not dance, and the universe as we know it would unravel like smoke in the wind. Among all the scientific mysteries that defy explanation, dark matter stands alone in quiet command, a vast presence felt but never seen. It watches from the shadows, cloaked in silence, woven into the architecture of everything. And so we search, not just for particles or signals, but for understanding. What does it mean that most of reality is, to us, invisible? If the universe is a book, what if we have only read the footnotes? Perhaps the answers drift quietly in the dark, waiting for us to notice not what we can see, but what we cannot. Dark energy. There is a silence in space that deceives. When we look up at the night sky, it appears calm, frozen in its infinite vastness. Stars blink from unimaginable distances and galaxies drift like ancient lanterns in the dark. To the human eye, it seems serene. But beneath this stillness, the universe is changing, stretching, accelerating, driven by something we cannot see, cannot touch, and barely understand. It is called dark energy, and it is perhaps the greatest enigma in modern cosmology. The story begins with a simple question: what is the fate of the universe? Over a century ago, Albert Einstein introduced his general theory of relativity, a framework that viewed gravity not as a force, but as the warping of space and time. In this model, the universe could expand, contract, or remain static depending on its contents and the gravitational influence of mass and energy. At that time, Einstein believed the cosmos was eternal and unchanging. To maintain this static universe, he introduced a term into his equations, the cosmological constant, a mathematical trick to counteract gravity and keep the universe from collapsing in on itself. But just over a decade later, this notion of a static universe began to crumble. Astronomer Edwin Hubble observed that distant galaxies were moving away from us. In fact, the farther a galaxy was, the faster it seemed to recede. The universe wasn't static at all. It was expanding. Einstein reportedly called the cosmological constant his greatest blunder. For decades, scientists believed that this expansion, driven by the force of the Big Bang, would gradually slow down due to the gravitational pull of all the matter in the universe. Then came the breakthrough that rewrote everything. In the late 1990s, two independent teams of astrophysicists studying Type Ia supernovae, exploding stars that serve as cosmic mile markers, discovered something shocking. These distant supernovae were fainter than expected, not because they were dim, but because they were farther away than previously thought. The universe wasn't just expanding, it was accelerating. Some unseen influence was overpowering the attractive force of gravity, driving galaxies apart at increasing speeds. The name given to this hauntingly elusive force was dark energy. Today, we estimate that dark energy makes up nearly 70% of everything in the cosmos. 70%. And yet we do not know what it is. It does not emit light, nor does it interact with matter in any direct way we can measure. It operates only on the largest cosmic scales, shaping the entire universe while remaining completely invisible. There are theories, of course. The cosmological constant has made a dramatic return, now interpreted not as Einstein's blunder, but as a candidate for what dark energy might be. A constant energy density embedded in the very fabric of space. According to this idea, as the universe expands, more space is created, and with it, more dark energy. This results in a runaway effect, with expansion feeding more expansion. Other theories are more exotic. Some physicists propose the existence of a mysterious field, sometimes called quintessence, that fills space and has properties that change over time. Still others suggest that dark energy is a sign that our understanding of gravity may be incomplete, prompting radical reimaginings of physics itself. And yet, none of these ideas have provided definitive answers. Every attempt to detect or describe dark energy directly has ended in silence. Instruments capable of peering across billions of light years tell us that the universe is speeding up, but they do not whisper why. One of the most haunting aspects of dark energy is not just what we don't know, but what it suggests about the future. If the acceleration continues indefinitely, galaxies will ultimately drift so far apart that they will vanish from one another's view. Over unimaginable spans of time, stars will die, and even black holes will fade into cold oblivion. And the universe, once vibrant and seething with energy, will grow dark and empty. A scenario called the Big Freeze, a cosmic silence that stretches into eternity. Yet this vision is not set in stone. It is only one possible ending among many. What if dark energy isn't constant? What if it turns off or even reverses? Could the cosmos collapse back in on itself in a big crunch? Or is something even stranger waiting in the wings? A sudden tearing apart of all structures, down to the fabric of atoms. In what some call the Big Rip, these aren't just poetic speculations. They are echoes of our ignorance, reminders of just how little we truly grasp about the universe that cradled our birth. Consider this. Every second, more dark energy is being added to the universe as space expands. It behaves not like a traditional substance, but like an intrinsic feature of the cosmos. Whatever it is, it knows no boundaries. It cannot be shielded against, and yet we are utterly unaware of its presence in our daily lives. A force that dictates the destiny of stars and galaxies, while we rarely think of it at all. There is a symbol, little known, drawn from the ancient Kitab al-Majisti, a medieval text that preserved the astronomy of antiquity. It is a swirling ellipse around a central void, an image once used to illustrate the unknowable force sustaining the motion of celestial spheres. In its emptiness, there is suggestion. Not absence, but the presence we cannot name. A fitting emblem for dark energy, the silent breath of the cosmos. In our exploration of the unknown, few concepts stretch the limits of imagination like dark energy. It is the backdrop and the engine, the invisible ink upon which the story of the universe is written. It remains a shadowed chapter in the book of physics, a mystery not just unexplained, but perhaps temporarily unexplainable. Tonight, as stars glimmer above and time unfurls in quiet procession, we are reminded that the universe holds its secrets tightly, and dark energy, silent and unyielding, may be the whisper that binds them all. As we drift between galaxies and gaze into the blackness, we may ask, what is the true shape of nothing? And what else might it be hiding? Ball lightning. Imagine a storm. Thunder drumming low across an endless sky, rain sweeping in silver veils. the world lit, mid-breath, by sudden forks of lightning, carving through clouds like fingers of fire. Now, picture this. As the last echoing boom fades, a glowing orb, pulsing, humming, eerily suspended in the air, floats silently through the open doorway of a farmhouse, or hovers just inches above wet grass, rotating slowly as though inquisitive. This is ball lightning, a flickering phantom of nature that has puzzled scientists, awed witnesses, and danced at the edge of explanation. From ancient texts to modern encounters, across cultures and continents, reports of ball lightning are remarkably consistent, and yet maddeningly elusive. Said to range in size from a marble to a basketball, these luminous spheres often appear during thunderstorms. Yet, unlike ordinary lightning, they move unpredictably, drift slowly, and vanish, sometimes in silence, sometimes with explosive force. They've been described as orange, blue, white, even green. Some pass harmlessly through walls, others leave scorched traces. But more often, they leave nothing at all, except stunned silence and a lingering sense of the unreal. One of the earliest known accounts comes from a letter written in 1753 by a Russian scientist named Georg Richtmann. As the story goes, Richtmann was experimenting with a kite during a thunderstorm, an endeavor not unlike that of Benjamin Franklin, when he allegedly encountered a glowing sphere that struck him dead. A tragic coincidence, perhaps. Or if the reports hold truth, one of the first recorded fatalities attributed to ball lightning. Since then, thousands of sightings have surfaced, from battlefields to passenger planes. In 1963, on a British airliner flying over the Atlantic, pilots reported a luminous orb entering the cockpit, floating along the instrument panel, then vanishing silently. The plane was unharmed, the crew unscathed, but the mystery deepened. How could such an object, if it is even fair to call it that, appear inside a sealed, pressurized environment, traverse electrical equipment, and disappear without a trace? Scientific attempts to explain ball lightning have explored diverse avenues. Some theories suggest it's a kind of plasma, a superheated, ionized gas somehow stabilized by magnetic fields. Others propose it may involve microwave interference trapped in a bubble of air. There are even radical notions involving antimatter or miniature black holes, though such ideas often stretch into the speculative. As of today, no consensus exists. No laboratory has been able to consistently recreate it, and still, the phenomenon endures, not as myth, but as reported experience. Unlike many folktales that fade under scrutiny, ball lightning walks the delicate line between the intangible and the observable. Even modern science, armed with satellites, sensors, and simulations, struggles to catch it in the act. Occasionally, someone manages to capture a shadowy flicker on film, or sensors pick up anomalies that might match descriptions. But proof remains eternally just out of reach. What makes ball lightning especially seductive as a mystery is the way it refuses to belong neatly to one category. It is natural, yet seemingly unnatural. Ephemeral, yet dangerous. It behaves like energy, yet sometimes suggests a peculiar intelligence, reacting to environments in ways that hint at awareness. Of course, this is likely projection. We assign intention where there is only reaction. Yet isn't that what we do with all true mysteries of nature? We watch the unknown through the eyes of wonder. The Chinese classic texts of the Jin dynasty mention glowing spheres appearing after thunderstorms. Some Zen scrolls depict orbs floating above trees during times of political tension, interpreted by scholars both as spiritual signs and meteorological phenomena. In Aboriginal Dreamtime stories, floating fireballs danced in ceremonial places, guiding or warning those who watched with the right eyes. Across time, across cultures, humanity has framed the experience within its own symbolic narratives. In alchemical traditions, a burning sphere suspended in air was thought to be a visitation from the volatile spirit of Mercury, an element known for its elusiveness, for escaping definition. From symbolism to science, researchers have tried to understand ball lightning through controlled tests. In 2006, scientists in China accidentally captured what they believe may have been ball lightning on high-speed video, using spectrometers during a thunderstorm. The glowing ball appeared after a lightning strike, floated for several seconds, then disappeared. Its spectral analysis showed silicon, iron, and calcium, elements from soil vaporized by the strike. This lends weight to the theory that ball lightning might be a kind of silicon-based plasma. And yet, skeptics suggest it could merely be an optical illusion caused by conventional lightning. Confirmation remains just out of reach, and so, ball lightning lingers, both in the skies and in the margins of science. It presents itself rarely, leaves little behind, and demands humility in the face of the unexplained. In a world increasingly mapped and measured, there is something quietly exhilarating about phenomena that still escape the grid. They remind us that nature, even in the age of algorithms and particle colliders, still keeps some secrets. We live in a time where knowledge grows by the second. New elements are forged, deep oceans explored, distant stars catalogued. And yet, a glowing orb of unknown origin can still drift through the air, unbidden, unmeasured, ungrasped. Ball lightning may be real or an exotic trick of perception. It may be studied one day in high school physics classes, or it may remain forever unexplained, a shimmering fragment of the sublime. In the end, perhaps the most fascinating truths are not answers, but the questions that persist. If something so simple, a ball of light, can defy categorization for centuries, what does that say about the limits of our understanding? What else lingers just beyond perception, waiting for the quiet moment when the lights flicker and something strange glides by, just out of reach? In the hush that follows a storm, as the sky lets go of its fury and the air feels charged and watchful, we are reminded that the universe is still capable of surprise. And somewhere, perhaps, when all is still, a sphere of light awakens and drifts silently through the night. Quantum entanglement. In the shadowy spaces between what we know and what we dare to imagine lies a phenomenon that seems to violate the very rules of physical distance. It whispers between particles across vast stretches of space and time, binds them in ways that defy conventional logic, and leaves even the most brilliant minds in science contemplative and silent. This is quantum entanglement, a thread tugging at the edge of our understanding. Imagine two particles, born together in a fleeting moment of creation. They might be photons, electrons, or more exotic configurations of matter and energy. Once entangled, no matter how far the particles drift apart, across inches, meters, or light years, they remain connected. Observing the state of one instantaneously determines the state of the other. It is as though they are reading each other's minds, responding in synchrony to measurements separated by time and distance. This isn't science fiction, it is experimental fact. Albert Einstein found the idea unsettling. In 1935, he referred to it as spooky action at a distance, and used it as part of an argument that quantum mechanics might be incomplete. To him and to many, the thought that a measurement here could affect something over there, without anything passing in between, violated the principle that nothing can travel faster than light. Yet experiment after meticulous experiment has confirmed that entangled particles do indeed behave in this incomprehensible manner. In 1964, physicist John Bell devised a groundbreaking theorem. He showed that if quantum mechanics was incorrect, if theories like Einstein's hidden variables were right, there would be mathematical limits to the kind of correlations we should expect between entangled particles. But when these tests were finally conducted decades later, the results consistently sided with quantum mechanics. The particles were correlating in ways that no classical chance process or hidden variable could explain. The implications are profound. Entanglement suggests that information, or at least influence, may not be constrained by space in the way we have always believed. In a world where cause follows effect in neat succession, entanglement stands apart. It tells us there may be woven structures in the very fabric of reality that connect distant objects in ways we cannot yet comprehend. Some physicists imagine the universe as an intricate tapestry of relationships rather than isolated parts, a network rather than a machine. From this view, entanglement is not a glitch or anomaly, but a window into the fundamental unity beneath what we perceive as separation. It challenges the notion of locality, that what happens here cannot instantly affect what happens there. It swings open doors to questions about time, space, and the meaning of connection itself. And yet, for all its strangeness, entanglement is not an abstract curiosity. It is real, measurable, and increasingly usable. In recent years, scientists and engineers have begun harnessing this baffling effect. Quantum encryption, for instance, employs entangled photons to create ultra-secure communication channels. In theory, any eavesdropper would collapse the entanglement, revealing their presence instantly. Entangled particles may one day be the linchpin of a new kind of internet. Quantum networks linking minds and machines in delicate, instantaneous synchrony. But even as we begin to use entanglement, our understanding of it remains obscured by unanswered questions. What does it mean for two particles to be connected? Where is the information stored? And how is it transmitted? Or is there some deeper mechanism we are still missing? Some propose that space itself is an illusion, a construct that emerges from entanglement rather than the other way around. According to this radical idea, the geometry of the universe is not the stage upon which entanglement acts, but a shadow cast by an unseen pattern of underlying links. There is a lesser-known symbol, found engraved on ancient Sufi manuscripts, the geometry of two overlapping circles forming what's called the Veisika Piskis. It represents the space where two realms intersect, a blending that is neither wholly of one nor the other. It is perhaps an uncanny metaphor for entanglement, a mysterious intersection where the boundaries of separation blur. Not two, not one, but something in between. Still, we must be careful. Quantum entanglement does not allow us to send messages faster than light, at least not in any conventional sense. The correlation between particles is only revealed when we compare results afterwards. Though immediate, it is oddly mute. Like a musical duet between partners unaware of each other until the final note, the harmony is there, but its significance is realized only in retrospect. And so we return to this quiet enigma, floating at the edge of modern physics. A phenomenon that refuses to be confined by our definitions of space and time. It confronts us not just with mathematical puzzles, but with philosophical ones. Are particles communicating through a hidden medium? Or is our understanding of separation itself the illusion? In the context of scientific mysteries that defy explanation, quantum entanglement may be the most haunting of all, not because it remains unexplained, but because in its very explanation, it reveals just how little we truly know. It's a message in a language we are only beginning to decipher, painting an image beyond the edges of our current maps. Perhaps in some far future, we will look back on entanglement not as a curiosity, but as a portal, an invitation to rethink the laws we take for granted. Until then, we watch as entangled particles drift apart, yet remain united, tethered by invisible strings. And we are left wondering, not just what connects them, but what, in the end, connects us all. The WOW signal. It was a quiet evening on August 15th, 1977. At Ohio State University's Perkins Observatory, nestled among the cornfields and calm skies of Delaware, something truly unusual was intercepted. Not by accident nor by chance, but as part of a deliberate search for artificial signals beyond Earth. A project called SETI, the Search for Extraterrestrial Intelligence, had been scanning the cosmos with a radio telescope affectionately named the Big Ear. Astronomers had forever wondered, if intelligent life exists other than us, how might we detect it? What form would its message take? Amidst the sea of cosmic noise, buried under the steady hum of earthly transmissions and natural celestial signals, how could something intelligently crafted emerge? The Big Ear telescope wasn't trying to hear voices or decipher languages. It listened instead for narrowband radio signals, signal types that, by nature, don't commonly occur in the chaos of stars or magnetic storms. In particular, the telescope was trained on a frequency near 1420 megahertz. That number might seem random, but it isn't. It corresponds to the emission frequency of neutral hydrogen, the most abundant element in the universe. Universally significant, universally silent. Quiet, in a way that speaks volumes. For centuries, hydrogen has whispered across the galaxy. To scientists, This claimless channel became a logical choice for extraterrestrials to use, the so-called water hole of the radio spectrum, where intelligent life might coexist in unspoken harmony. On that August night, as the telescope methodically scanned across the heavens, it picked up something remarkable. A 72-second signal, intense and narrow band. Once processed through the system, it stood out so clearly on the readout printout that astronomer Jerry Amon, upon reviewing the data a few days later, famously circled the sequence of numbers and letters, 6EQJ5. He drew a line in red ink and scrawled one word beside it. Wow, the wow signal. What made that moment so gripping wasn't only the strength of the signal, roughly 30 times the background noise, but its nature. It fit many of the characteristics scientists expected from an alien transmission. It was specific in frequency, strong in amplitude, and unique. It lasted 72 seconds, the length of time the sky passed through Big Ear's fixed beam, and then it was gone, never to be heard again. And that's where its beauty lies. The silence that followed has only deepened the mystery, because after decades of follow-up observations, the wow signal has never repeated. We've never been able to confirm its origin, whether interstellar or otherwise. It came and it went, without a trace. Imagine for a moment, a beam from the depths of interstellar space, a whisper across unimaginable distances, perhaps from a civilization older than our own, tuned to connect with others through the shared physics of hydrogen. Or perhaps it was an echo, light years away, of some long-dead transmitter, a cosmic artifact like a bottle floating in a voided cosmic sea. What exactly could have produced such a signal? Over the years, scientists have investigated countless possibilities. Some theorized a satellite, though none were in the right position. Others proposed terrestrial interference, yet the spectrum of the wow signal didn't match anything we know from Earth-based sources. Then there were suggestions of natural astrophysical phenomena, pulsars, quasars, or interstellar hydrogen clouds. But again, nothing fit the signal's profile. Nothing explained the intense, clean nature of what was received. In 2017, a new theory emerged. Antonio Paris, a professor and former analyst, suggested that the signal may have been caused by the hydrogen clouds accompanying two comets, 266P/Christensen and P2008Y2, passing near the observation field at the time. This promising idea offered an earthly explanation, grounded in physics and orbital mechanics. Yet, when others tried to replicate the conditions, they found that the comets weren't emitting signals strong enough to account for what the Big Ear detected. The sky, it seemed, was still keeping its secrets. In our age of advanced signal processing and powerful telescopes, eyes that scan deep into radio silence, we have still not pinpointed the origin. The wow signal remains a singular anomaly, a 72-second challenge in a universe full of questions. And this is the allure of scientific mysteries that defy explanation. They live in that liminal space between what we know and what we reach for. For many, the wow signal is a tantalizing possibility. We may have heard, if only for a moment, a message not meant for us, not directed, not intentional, just received. There's something haunting about that across billions of stars and uncountable distances, a momentary fluke may have crossed paths with human curiosity. That of countless nights of silence, one became something more. Astronomers still listen. Modern successors to Big Ear look toward the same regions of space, hopeful. Instruments like the Allen Telescope Array and networks scanning frequency bands far wider than the 1420 MHz channel. Because science, even when faced with mystery, does not sleep. It waits. It welcomes skepticism, and it surrenders, when needed, to wonder. Within its sequence, 6EQJ5 hides another lingering symbol. The code itself reflects the intensity of the received signal, ranging from numbers to letters signifying strength over background noise. But to some, it's taken on additional meaning. a quiet badge of optimism, a symbol that we might not be alone. Even decades later, the strip of handwritten paper with "Wow" in red ink is still preserved. An artifact of science, yes, but also an icon of curiosity. It reminds us that discovery often begins not with certainty, but with anomaly, with something that doesn't fit, and quite possibly never will. Perhaps we will detect another signal. Perhaps not. Perhaps the universe is teeming with intelligent life, signaling across the hydrogen line, and our brief glimpse was evidence. Or maybe, more hauntingly, we were listening when no one else was speaking. Alone, in between transmissions never meant for us. Underneath the data and the astronomical jargon is something deeply human. Our need to understand, to connect, to know. Every now and then, a moment comes that makes us pause and ask, what if? The stars are still out there, whispering. And so we continue to listen. In a universe rich with patterns and predictable laws, why did one signal break the mold? Why did it come and never return? And if something or someone spoke across the void just once, why were we the ones to hear it? The immortal jellyfish. In the vast, pulsating expanse of the ocean, beneath the surface where sunlight dissolves into shadow, drifts a creature ancient and small. At first glance, it might escape notice, transparent, delicate, about the size of a pinky nail. But hidden within its unassuming frame lies something almost mythic, the ability to reverse time. This is Turritopsis dohrnii, known quietly by another name, a name that hints at the impossible. The immortal jellyfish. It floats unchanged through centuries of water, carried by gentle tides and silent currents, a flickering emblem of life that refuses to follow the rules. And in this creature's remarkable gift, we face a scientific mystery that both dazzles and defies explanation. Discovered in the late 1800s, Turritopsis dohrnii remained relatively unnoticed for much of modern science. Its secrets weren't truly uncovered until the 1990s, when researchers began observing something unprecedented. Instead of growing old and dying, this jellyfish could revert itself, transforming back into its youthful state, like a butterfly morphing back into a caterpillar, again and again. For biologists, it was a revelation. For time, a quiet defiance. Most jellyfish go through a predictable life cycle. An egg becomes a larva, which becomes a polyp, then a medusa, the adult form we recognize drifting in the sea. But Turritopsis can take that final adult form and reverse it, tumbling backwards through its biology and restarting as a polyp once more. Not just once, but over and over. How it does this is only partially understood. The process is called transdifferentiation, wherein one type of cell morphs into another. Muscle cells become nerve cells. Reproductive cells transform into digestive ones. A biological alchemy that rewrites the jellyfish's body. It's not simply regeneration. It's renewal, the cellular equivalent of rewriting your own story from the beginning. Imagine a book that once finished doesn't end, but starts again with the same first page, rewritten by the very same paper it had filled. That's what Turritopsis dohrnii does. And perhaps even more striking, it doesn't age in the way other creatures do. Instead of accumulating damage or genetic decay over time, it resets itself, a perpetual loop within an ocean that forgets nothing. But this alluring concept, biological immortality, is far from simple. Though this jellyfish has the potential to live forever, that doesn't mean it always does. It can still be eaten, fall sick, or succumb to changes in its environment. Immortality, for it, is not invincibility, but possibility. A window to a life without aging, rather than a promise of eternal life. Still, this subtle distinction does little to temper the excitement or the deeper philosophical questions its existence raises. Why would evolution allow such a trait? How did this ability arise in a species so small and simple, while more complex organisms remain chained to entropy and decay? And could we, in time, learn from this jellyfish's self-reprogramming? Science stands at the edge of the metaphorical reef, peering in. Researchers have begun trying to uncover the precise genetic blueprints behind Turritopsis's phenomenal ability. But as with many biological marvels, each answer reveals deeper intricacies. No singular switch, no magic gene, just layers of interactions, patterns hidden in plain sight. Like the Ouroboros, the ancient symbol of the serpent eating its tail, representing the eternal cycle of destruction and renewal. Is that what this jellyfish is? Nature's own Ouroboros made flesh? Even beyond its biological capabilities, it challenges our understanding of time itself. Most of nature follows the arrow of time forward, just as we humans experience birthdays, aging, and eventual departure. But here is a creature charting its own course, erasing the lines we thought time drew into flesh. Could this jellyfish be a distant mirror, reflecting back on us a future we can barely yet imagine? A future where aging becomes malleable, life a gentle tide rather than a finite journey? Already, some scientists are looking to Turritopsis for potential medical breakthroughs, ways to reprogram cells, reverse damage, extend vitality. But even as we explore those avenues, we grapple with another question. Should we? What would it mean to interrupt the natural cycle, to bend biology to our will in such profound ways? In seeking answers from the immortal jellyfish, are we dancing with something deeper, a hidden rhythm of life we do not yet understand? Or are we simply standing at the edge of a deeper ocean of mystery? These questions ripple through the scientific world as researchers and philosophers alike turn their gaze toward this translucent being, not just because it challenges known biology, but because it inspires awe. In a world ordered by limits, decay, and endings, it represents a kind of quiet rebellion, an echo of the sublime within the microscopic. And so, deep beneath the crashing waves, the immortal jellyfish continues its eternal loop, gliding through its private time. Not loud, not dramatic, just certain. And human curiosity follows it downward, into waters we do not yet fully understand. In the end, the mystery of Turritopsis dohrnii is more than just a puzzle of cells and cycles. It is an invitation to consider the unseen knots in nature's tapestry, to wonder at the stories life tells in silence. And like so many scientific mysteries that defy explanation, it leaves us gazing not only at what is, but at what might be. Could immortality live not in stars or stories, but in a creature no larger than a fingernail dancing in the sea? Perhaps immortality is not a destination, but a rhythm. Perhaps, somewhere in the depths, time listens, fast radio bursts. Out there in the deep velvet dark of the cosmos, beyond the glowing swirl of our Milky Way, beyond even the whisper of its spiral arms, something is calling. A flash, a spark, a fleeting crackle of possibility. For less than the blink of an eye, it screams across unimaginable distances. And then, silence. As quickly as it appeared, it is gone. This is the strange and haunting tale of fast radio bursts, one of the universe's most electrifying riddles and one of the most elusive. The story begins not with a telescope pointed at a star, but with one listening to the static. In 2007, astronomers combing through old data from the Parkes radio telescope in Australia stumbled across an unexpected spike. Just 5 milliseconds long, it was like nothing seen before. A sudden, intense burst of radio waves. First thought to be a mechanical glitch, something too strange to believe. But stranger still, it didn't come from Earth. It came from somewhere far beyond our galaxy. In the years that followed, more of these anomalies were found. Some from archival data, some in real time. They were dazzlingly brief. Most lasted just milliseconds. But they were powerful. In that tiny fraction of time, a single burst could release more energy than our sun produces in days. And yet, their sources remained hidden, scattered randomly across the sky, flaring up without warning, vanishing without a trace. Fast radio bursts, or FRBs as they've come to be known, are lightning in the cosmic fog, almost impossible to spot, and harder still to predict. For over a decade, they were all one-time events, never to be heard from again. Until, in 2012, scientists detected something unprecedented, a repeating FRB, one that pulsed not once but many times. Known enigmatically as FRB 121102, its reappearance changed everything. Astronomers began to trace its signals, eventually locating its origin in a small, dim dwarf galaxy more than 3 billion light-years away. This tiny beacon, nestled in a far-flung corner of space, became a lighthouse of mystery. For the first time, we could fix an FRB to a specific part of the sky. It was a clue, a whisper of the mechanisms behind this cosmic phenomenon. But the more we discovered, the deeper the enigma grew. Some FRBs, like 121102, repeated. Others never returned. Some flashed in patterns, some in chaos. In 2020, one was found that echoed in a 16-day cycle, like celestial clockwork hidden within randomness. What could do this? What could scream for an instant across eons of darkness, then fall quiet once more? The theories came quickly. Magnetars, collapsed stellar remnants, dense with magnetic fury, black holes colliding, hypothetical cosmic strings, remnants of the early universe's symmetry breaking, left behind in the fabric of space-time like cracks in crystal. Or maybe something entirely new, something we haven't imagined yet. There are whispers, too, on the fringe of science. Suggestions of intelligence. Ideas that perhaps we're listening to something built deliberately. Not natural, but designed. A possibility that hangs just on the line between science and speculative poetry. Unlikely, perhaps. But FRBs remind us that unlikely is not the same as impossible. In April of 2020, another twist. An FRB was detected from within our own galaxy. A relatively nearby magnetar, SGR 1935 plus 2154, suddenly emitted a radio burst echoing the characteristics of extragalactic FRBs, adding weight to the idea that magnetars may be the culprits, at least some of the time. But even then, questions unfold. That galactic burst was powerful, yes, but still paled in comparison to some of the immense flashes seen from beyond. Could one phenomenon alone explain them all? Or are we catching glimpses of many events, tied only by the signatures they leave behind? The observations now flow like a slow but steady stream. Telescopes around the globe, and beyond it, are listening. Instruments like CHIME in Canada, with its wide field of view, have catalogued hundreds. Each new pulse is like a fingerprint on the edge of the unknown. Yet, no consistent progenitor has emerged. No single theory holds all of the answers. And so, they remain. Scientific mysteries that defy explanation. Each FRB a question mark hurled out into space. Each detection a reminder of how much we don't know, how small our understanding really is in the face of cosmic complexity. Perhaps what's most unsettling and most beautiful is the scale. These bursts come to us through oceans of time and space. A single whisper, from a source so far that it may already be gone, consumed, collapsed, or forever changed. And yet, its signal endures, finding us, touching our instruments with the lightest sigh of its existence. There are certain things in science that start with answers and lead to facts. But FRBs began with an accident, an anomaly, and have only ever offered questions. They step outside the neat diagrams and predictable patterns. They illuminate the edges, like shadows cast by stars we'll never visit. In an ancient symbol known as Ouroboros, the serpent eating its own tail, there is the idea of eternal cycles, a loop with no beginning or end, constantly feeding itself. In many ways, the pursuit of understanding FRBs echoes that symbol. Each clue feeds new mysteries. Each discovery creates a fresh frontier. And yet, something about that is comforting. That in our tangled search for certainty, the universe still holds secrets from us. That not all answers are within reach. As our instruments grow sharper and our maps of the sky ever more detailed, we listen not just for solutions, but for wonder. So the next time you look at the stars and see only quiet light, remember there are whispers between them, flashes that come and go, faster than thought, bursts that may never repeat, or might be pulsing, even now, behind the static. What is speaking across the cosmos? And will we ever understand what it's trying to say? The Tunguska Event. In the cold dawn of June 30th, 1908, high above a remote stretch of Siberian forest near the Podkamennaya Tunguska River, something extraordinary occurred. At precisely 7:17 in the morning, the sky ignited with a light brighter than the sun. Moments later, an immense explosion tore through the landscape, flattening over 2,000 square kilometers of forest, snapping millions of trees like matchsticks, and sending atmospheric shockwaves that circled the globe. No crater was ever found. To this day, more than a century later, the Tunguska Event remains one of the greatest unsolved mysteries in the annals of science, a moment of staggering natural force that left no definitive trace of its origin. What fell from the sky that day? What caused such devastation, yet vanished without a shard of proof? Eyewitnesses, who lived as far as hundreds of kilometers from the epicenter, described a column of fire streaking across the morning sky, a thunderous roar, and a heat that singed skin from miles away. Entire herds of reindeer, central to the region's nomadic Evenki herders, perished instantly. Trees lay flattened in a radial pattern, pointing away from a central point like the spokes of a great wheel. And still, in the very center of this vast circle of destruction, the trees stood scorched but strange, stripped of branches, like blackened poles piercing the air. Scientists were slow to respond. Due to political unrest and the remoteness of the site, it wasn't until 1927, almost 20 years after the event, that an expedition, led by Russian mineralogist Leonid Kulik, journeyed to the Tunguska region to investigate. Kulik expected to find a crater. He expected meteorite fragments, shrapnel of stone or iron scattered across the Siberian taiga. But instead, he found silence. Flattened forest, yes, but no impact site, no definitive debris, only deep bogs, charred wood, and the whispering wind. Kulik proposed that a meteoroid had exploded in midair just before impact, what scientists call an airburst, much like a small planetoid of stone or ice shattering violently due to its own speed and the pressure of Earth's atmosphere. The energy released in that instant, scientists estimate, was equivalent to between 10 and 15 megatons of TNT, roughly 1,000 times more powerful than the bomb dropped on Hiroshima. There are equations and models that support this. There are satellite records of similar, smaller events that have occurred in modern times, most notably the Chelyabinsk meteor in 2013. And yet, Tunguska refuses to align itself neatly with expectation. No definitive fragment has ever been found. Alternative theories populate the fog of this mystery, some scientific, others far more fringe. Suggestions range from a comet nucleus made of ice and gas that disintegrated completely, to underground gas eruptions, to black holes grazing the Earth. Nikola Tesla's wireless energy experiments have even been implicated in some theories, with the thought that his powerful Wardenclyffe transmitter accidentally discharged toward the Siberian wilderness with devastating results. These ideas hover between possibility and imagination, feeding the ever-burning fire of curiosity. They are the lifeblood of scientific mysteries that defy explanation. Then, there is the curious cultural parallel. The indigenous Evenki people, whose ancestors witnessed the blast, describe a powerful figure named Ogdi, the god of thunder. According to legend, Ogdi was angered by the actions of man and hurled fire from the sky to punish the earth. In their oral tradition, the Tunguska event becomes not merely a natural disaster, but an act of divine retribution. Echoes of fire-falling myths run deep across human history, from the Christian legend of Sodom and Gomorrah to the Phoenix of Egypt, consumed in flames only to rise again. These resonances, poetic but persistent, bridge the realms of science and symbolism. In 2007, a team of scientists claimed that Lake Checo, A small and unusually deep lake 5 miles from the blast zone may in fact be the long-missing impact crater. Sediment analysis revealed distortions suggestive of a sudden formation, perhaps consistent with a meteorite impact. But follow-up studies could not unanimously confirm this. The debate continues. Quiet, technical, unresolved. To some, the lack of hard evidence is precisely what points to a comet. It's mostly icy structure vaporizing in near totality during the airburst. But this raises questions of its composition, trajectory, and the unique nature of the explosion. Could something else be at play? A class of interstellar object, unknown and undetected, the kind that doesn't leave debris as we understand it? Something that flirts with the boundary between what we expect from physics and what remains hidden beyond it. The true cause of the Tunguska event continues to elude final classification. It exists in a space of uncertainty, tethered to data and grounded in physical possibility, yet always just out of reach. Each new study adds a brushstroke to the canvas, but the painting remains unfinished. A century on, the trees have regrown. Satellites now pass over the once flattened expanse, and mankind has unleashed energies that rival the ancient blast. But still, we pause when we consider Tunguska, because there, in the heart of the Siberian wilderness, lies a reminder that even in an age of reason, of measured mechanisms and quantifiable truths, there remain phenomena that defy complete comprehension. Events that whisper the limits of our understanding, like wind over ash. Perhaps, one day, the mystery will be fully understood. Perhaps new technology or insight will unveil the long-concealed key. Or perhaps, like the fading sound of distant thunder, it will remain elusive. A symbol like the Ouroboros, endless return and eternal unknown. A scientific mystery that defies explanation. And so we are left with the silence of the forest, the flattened trees standing like fallen sentinels of time, and the eternal question: what was it exactly that came from the sky on that quiet morning in 1908? And why did it come at all? Ultra-high energy cosmic rays. High above our heads, beyond the thin shell of atmosphere that cradles our existence, there is a storm of invisible particles silently streaming through the cosmos. Most of them pass through us without notice, slipping between the molecules of our bodies, indifferent to our presence. These are cosmic rays, tiny travelers from space, constantly pelting Earth in an endless rain. But among them, there exists a rare and enigmatic elite, particles of such unfathomable energy that they defy the limits of our understanding. These are the ultra-high energy cosmic rays, and they are among the greatest scientific mysteries that defy explanation. To understand the scale of what we're talking about, consider this. A single particle of an ultra-high energy cosmic ray, just one proton, can carry as much energy as a baseball thrown at your head. That's not metaphorical, that's literal. A single subatomic particle traveling across the cosmos, from who knows where, collides with our atmosphere at a velocity and energy that challenges our very models of physics. They were first hinted at in the 1960s, when detectors across the globe began capturing anomalies. Showers of particles produced in the upper atmosphere, cascading down like waterfalls of energy. Most cosmic rays are relatively modest in strength, but occasionally, something exceptional was observed, something profound. A cascade so intense that it defied models. These ultra-high energy events suggested sources beyond anything we had imagined. In 1991, a particularly startling detection occurred. At the Fly's Eye detector in Utah, a cosmic ray was recorded with an energy of over 3x10 circumflex 20 electron volts. To put it plainly, this was a particle that struck Earth with more than 40 million times the energy produced in the most powerful particle accelerators humans have ever built. Scientists referred to this as the "oh my God" particle. Not for its poetic flair, but because that's exactly what researchers exclaimed when they reviewed the data. Even today, more than 30 years later, we don't know where it came from. Ultra-high energy cosmic rays, or UHACRs, are not supposed to exist in our current framework of physics. According to prevailing theories, Particles at this level of energy should interact with the ever-present photon fog of the universe known as the cosmic microwave background. These interactions should drain their energy long before they ever reach Earth. This is called the Greisen-Zatsepin-Kuzmin limit, or GZK cutoff, and it predicts that cosmic rays above a certain energy simply cannot travel more than about 150 million light-years without losing power. Yet, they do. Somehow. So where do they come from? That is the looming, unanswered question. The most violent environments in the known universe, collapsing supernova, active galactic nuclei, spinning neutron stars, have been considered as candidates. But no model convincingly explains how a single proton could be accelerated to such an extent. What kind of cosmic machinery could hurl a particle across unimaginable distances, at energies that seem to mock the limits set by the universe itself? There are theories, certainly. Some speculate these rays originate in galactic superstructures, collisions between galaxies, or jets fired from supermassive black holes. Others suggest more exotic explanations, the decay of prehistoric particles left over from the Big Bang, or even evidence of topological defects in space-time, such as cosmic strings, ancient remnants of the universe's formation, knotted into the very texture of reality like creases in time. These are profound and unsettling ideas, and they remain far from proven. We've built vast observatories to monitor them. The Pierre Auger Observatory in Argentina spans over 3,000 square kilometers, using both an array of detectors on the ground and telescopes to capture the faint ultraviolet flashes produced when cosmic rays strike our atmosphere. It's a silent watchtower, stationed at the bottom of the world, laboring patiently for clues. From above, it resembles a great grid inscribed into the land, a modern-day geoglyph dedicated to a mystery of the stars. And yet, even with these tools, we see only flickers. Events are rare. In a year, perhaps one ultra-high energy cosmic ray strikes every square kilometer of Earth's surface. Their tracks are fleeting and indistinct, almost like whispers written in wind. There has been no pattern, no preferential direction. The sky offers no compass to lead us toward their origins. Even stranger, recent studies suggest a slight asymmetry. More of these particles seem to arrive from a region of our sky near the supergalactic plane, aligning loosely with the distribution of nearby galaxies. But it's still murky, and such patterns, if real, would favor sources that lie within the GZK limit. That leads some to propose that these rays must be born somewhere close. Yet we have searched and found nothing nearby capable of such ferocity. Particles at this energy behave oddly. Their paths are twisted by magnetic fields, bending and writhing through space like kelp caught in ocean currents. By the time they reach Earth, their origin points have been obscured, like ripples in a pond whose source can't be located. And so we are left piecing together incomplete information, shadows on a wall. There is a strange symbolism lurking here, the unknown delivered to us on the back of a single particle, a messenger from afar. It's as if the cosmos sends us an occasional inscrutable relic, a relic that refuses to explain itself. The study of ultra-high energy cosmic rays sits at the edge of our knowledge, not just scientific boundaries, but philosophical ones. We are reminded of our fragility, our immense desire to comprehend a universe that rarely explains itself directly. These particles aren't just curiosities. They are confrontations, challenges to the symmetry and order we believe lurk beneath nature's surface. There is perhaps a poetic parallel in the ancient Norse rune alges, a symbol resembling the shape of a reaching hand or a branching path. It was once thought to signify connection to higher powers or cosmic protection. In the strange, invisible rain of cosmic rays, it's tempting to imagine the universe brushing against us with a similar gesture, offering hints, but no clarity. This is the spirit of scientific mysteries that defy explanation. Questions that don't yield easily, puzzles that may be teasing some hidden structure in reality we have not yet conceived. For now, the ultra-high energy cosmic rays continue their journey, striking Earth in silent collisions, unseen until caught by the delicate instruments we have laid across the surface of our world. But their origin remains cloaked in silence, a story written in impossible bursts of energy. We do not yet know from where they come, nor why they reach us. Perhaps we are not ready to understand, or perhaps we are looking in the wrong directions. Either way, they continue to fall, as uninvited visitors from the deep, and we are left, watching, wondering, waiting. What force, we might ask, reaches across the cosmic void to touch our small corner of space with such overwhelming strength? And might it reach again in ways we cannot yet see?